Here we go. So, solving multi-step inequalities. This is the same thing that we've already done. Okay? So, we did one-step equations, then we did multi-step equations. One-step inequalities, two-step inequalities. So, we're going to follow the same rules. Okay? So, numbers on one side, letters on the other. This is where it's more important to keep your letters positive. Okay, your variables positive. So since I have my 2x alone on the left side, I'm just going to add 5 to both sides. And we're going to get 2x is less than 12. Divide by 2, x is less than 6. And real quickly, how we graph that? Put a 6, open dot, that direction. That's it. Now, number 2, look at that carefully. See how the x is negative?
Yes.
Okay, we have two choices, and here's why that rule applies. Right now, x is on the greater than side, right? Everybody agree with that? Okay. Now, if I divide by -1, it's going to say x is less than, correct? Okay. But if I just move the x over and make it positive right now, what side is it going to be on? The less than side. That's why the rule works here. Okay? So I'm actually going to do that. I'm going to add x to both sides and get 5 is greater than x plus 4. Then I'm going to subtract 4 and get 1 is greater than x. Or x is less than 1. And then real quickly, how do I graph that? I put a 1, I put an open dot, and x is less than. Now, real quickly, let's just pretend I didn't do that. Let's pretend I moved the 5 over by subtraction. I would add negative x is greater than -1. Everybody agree with that? Okay. Then I would have to divide by -1, which would give me x is less than +1. Now, you can say, well, why would I do that? That's less work. It is. It's fewer steps. It's quicker. But you also have to remember the special rule. So it's your choice. If you're good with the rule, that's going to be quicker. Because you're only doing one move instead of 2 moves, plus getting rid of the negative. But it's your choice. Okay? Number 3, we're going to get rid of the 9 first. Now remember, since my r is positive, I'm not going to move that over. I'm going to subtract 9. And that's going to give me -12 is less than or equal to 2/3 r. Now don't get freaked out because it's a fraction. We just multiply by the what? Reciprocal, which means standing on its head. 3/2. And 3/2. This side's not important because it cancels. Again, you have two choices here. You can multiply 3 by -12 and divide by 2. Or for smaller numbers, divide 2 into -12, -6, times 3, -18. Your choice. Again, if you feel more comfortable rewriting it, remember the mouth is facing the R. You don't have to rewrite it like that. But if it's more comfortable for you or you feel better about it, do it. And then real quickly, I just need one number, -18. It's a solid dot, and it's greater than. Okay, let's skip number 4 because it's kind of like the same thing. Okay. Number 5, at the same time. Number 5, I want all my m's on the same side. So I do that. I'm going to subtract 4m. Uh-oh. What happens? 0. So I get the statement -17 is less than 25. True or false? Okay. So, since that's a true statement, what's my answer? All numbers. If I get a true statement, my answer is all real numbers. Because no matter what number I put in for m, it'll work out being true. Let's put in 0. I get that. If I put in 1, I get a true statement. No matter what I put in, I'll get a true statement. Okay, number 6 has a distributed property to go on. So over here, I have -6 less than, I have to send this 3 in. 15v minus 6, not minus 2. Now I'm going to add 6 to both sides. I don't know why I just did that. And I get 0 less than 15v. I know people are like, oh, it's 0, so just stop. No, 0 is still a number. I still need to divide by 15. So 0 divided by 15 is 0, less than v, also known as v is greater than 0. I'm going to graph that. Here's my 0, open dot, that way. Oh, and I forgot to graph this one. For all real numbers, you literally just, put a 0 there and just, it's everything. It's the whole number line. All right, we're just going to do a couple of these. Number 7 has distribution on both sides, so we're going to do that. So -5g, that's a g, not a q, minus 20, greater than 3g minus 12. Now remember, I think it's easier to keep your number letters positive. So if I move the 3 over, I'm going to have -8g. I don't want to do that. So I'm going to add 5g's to both sides. That gives me -20 is greater than 8g minus 12. Now I'm going to add 12 to both sides. I don't know why I did that again. Add 12. And that gives me -8 is greater than or equal. I'm just drawing extra lines today. I don't know why. Greater than 8g. When I divide by 8, I get -1 is greater than g, which means g is less than -1. Remember, the arrow is pointing towards g, the mouth is eating the -1. So when I rewrite it, I keep the same direction. And real quickly, when I graph that one, put a number -1, it's an open dot, okay? And g is less than -1. And then we'll go down to number, doesn't really matter, I'll do number 10, a little bit more work here. So, on this one, be careful that 2 only goes to the parentheses. It does not go to that extra 2. Okay? Some people get over anxious and distribute that 2 everywhere and they just don't stop. It's just those 2 numbers. So this is 9 plus 2t less than 2t plus, careful, 6, and this stays 2. I'm going to join those together and have 9 plus 2t less than 2t plus 8. I'm going to subtract 2t, which gives me 9 is less than 8. Is that a true statement? No. It is not a true statement. Therefore, there's no solution. Solution? No solution. Okay? You can put either symbol. Okay. kind of already done this, but this is less than. This is less than or equal. This is where we talked about at most or up to. Those are those words when you're translating. Yes, sir. Like we already said, this is greater than. This is greater than or equal. And this would be words like at least, if you're translating. So, when we're translating this, 4 times a number. So, times means multiplication. A number, usually x, minus is minus, is greater than, so that's going to be one of these, 8 plus 2 times the number. It's pretty much like it sounds. So, we just translate it. Word for word. 4 times the number minus 6 is greater than 8 plus 2 times the number. Now we solve it. I want to keep my x's positive, so I'm going to move the 2x over. I'm kind of limited on space, so I'm going to do both steps at once. The 6's cancel here, the 2x's cancel here. This gives me 2x is greater than 14. Divide by 2, x is greater than 7. Open dot, greater than. Last one. Number 12. Negative 3 times the number. So watch how hard this is. Well, there's negative 3. Okay? Times the number. Plus 4 is less than 5 times the number plus 8. It literally is word for word translation. That's it. Now, I want to keep my x's positive, so I'm not going to move the 5x to the left. I'm going to add 3x here. Which will give me 4 is less than 8x plus 8. Since I move my letters to the right, I want to subtract and move my numbers to the left. That gives me negative 4 is less than 8x. Now I divide by 8. I have a negative here. Do I flip the symbol? No. Did I divide by negative 8?
No.
No. Just seeing a negative does not flip the symbol. So that gives me negative 4 over 8 is just negative 1/2 less than x. Or x is greater than negative 1/2. Negative 1/2. Open dot. Greater than. I lied. One more. You have $25 at most to spend. So here's a 25 at most, which means less than or equal 25, right? Okay. If admission is $5, that's just a flat fee, and rides are $1.25 each, how many rides could you go on? So, first off, you subtract 5. That gives you 1.25x is less than or equal to 20. Remember, $25 is not the minimum amount you have, it's the most you have to spend. Now, you just divide by 125. So, x has to be less than or equal to 16. Okay, so 16 rides